Good morning, SS2 class. Good morning, Evelyn. Good morning, Chaba, Erimula, Martin, Bruno, Magdalena. I know you are sick, but you will be following us on YouTube. Good morning, Cindy. Good morning, Maria. Good morning, all those whose names I haven't mentioned. Not forgetting Obama. Yes, we are here to continue from what or where we left the other time. The other time we talked about sets, type of sets, and so on and so forth. Some of you have submitted your works, others too haven't, but I'm entreating upon you to make sure you send it so that I will print it out and then mark it and then keep it for you. Whenever school resumes, then I give it to you, because I need to record the marks. We are going to use it in grading you at the end of the term. So it is important, every work I ask you to do, you do. Thanks, Cindy. Cindy has brought S, Erimula, Martin, and then Evelyn. You have all brought yours. But Bruno, you haven't. If you have, maybe you haven't seen it. But I hope you do that. Maria, the one you brought was not the updated one. I've marked your book and then left it at the gate so that your mother will come for it. So that you will do it inside the book and then you give it to your mother to be given to me. Now today we are moving straight to the Venn diagram. I gave you a background to the inventor of the Venn diagram. John Venn. He was a British scholar, a mathematician, a statistician, and so on and so forth. We know about him already. Now, what we are going to talk about is about how to separate different elements without repeating them. For instance, this class, if you take this class as a universal set, as the mother set, and we are grouping them according to the type of food that the members they want or they like rice and then plantain. We will call those who like plantain. You see a certain number of students getting up or raising their hand, opting for plantain. Others too will opt for rice. Now you notice that there will be some elements or some members of students in class who like both plantain and then rice at the same time. Those people, when they call for rice people, they will go, they will be counted. The same people, when they call for plantain people, they will go, they will be recorded. Therefore, you realize that those people, that one group of people, they will go here, they will come here, and for that matter, they will be counted twice. So the Venn diagram basically is to separate these people. When you are given something like that or a problem like that to solve, all what you have to do is that you separate these two groups of people. You separate the plantain people, you separate the rice people, and then those who like plantain and rice, you separate them so that you get three groups of people. So the Venn diagram, it has the first region, second region, the third region, and then the fourth region. There will be some students who do not like plantain and they will not like rice. Those people are the ones we were referring to as complements. Those people, they will come to the fourth region. For instance, this is a sample of the Venn diagram. This is the universal set. This is the set of people who like plantain. This is the set of people who like rice. So plantain, rice. Those who like plantain only will come here. That is the region 1. Those who like plantain and rice will come in the second region. Those who like rice, they will come in the third region. And those who do not like plantain or rice, they will come to the fourth region. So that is how Venn diagram is supposed to be. The first region, the second region, the third region, and then the fourth region. The fourth region, as we have been talking about, belongs to the complement. They are the complement. They are part of the universal set. They are part of the class, but they don't like any of the fold. They not liking any of the fold doesn't mean they are not part of the universal set. It doesn't mean they are not part of the class. They are part of the class, but they don't like that fold. Now, without much to do, let's look at the questions on the board. We have question 1 and then question 2. We are going to take them to have a clearer understanding of what I really want to pass around. In a class of 40 students, 30 read maths and 20 read English. Each student read at least one subject. I illustrate the information on the Venn diagram. How many students read both subjects? So, for you to start with this, the moment you start with this question, you should know the answer already. Now, it says the class, the universal set, they were 40, but 30 were offering mathematics and 20 were offering English. Now, when you put 30 and 20 together, you get 50. Meanwhile, you are supposed, the people in the class are supposed to be 40. So there are some number of students who are exceeding. So the first trick for you is that whenever you are given a two-set problem and you are told to find those who are here or here, and for that matter, those who belong to this region, all what you have to do is that you add this and this together, and then you subtract it from this, and then you get those who are there. Now, 30, 20, we put it together, we get 50 students. 50 students, we subtract 40 from the 50 students, and then we will get 10. So before even we started, we already know our answer. But before we get to the answer, we have to generate something we call an equation. We have to generate an equation out of this, because everything should be equal to this. And I've told you that in mathematics, we have two types of expressions. We have mathematical expression, and then we have an equation. Wherever you see a mathematics problem with an equal to sign inside that statement, then it means that statement is an equation. Whenever you see something that does not include an equal to sign, that thing is statement is a mathematical expression. I hope you are aware of that. Now, let us quickly generate something out of this and then see what I really mean. Now, this is our universal set. This is our universal set. So it is represented like this. How many are they? They are 40. They are 40. Now, mathematics, how many were they? They were 30. Now, English, how many were they? They were 20. Yes, and it says we are to illustrate the information on the Venn diagram. We are illustrating the information on the Venn diagram. This is X, because we don't know the number of students who are here and there. But already, I've told you that this and this put together, we subtract this from that outcome. So 20 plus 30 gives us 50. 50 minus 40 will be 10. So even before we start, we already know that this place, they are supposed to be 10. But what shows that they are 10? Therefore, you have to prove it by means of the calculations. And the calculations is what we are about to do. So this place will be 30 minus x. And then this place will be 20 minus x. Yes. So we are generating the equation 30 minus x plus 20 minus x equals to the universal set, which is 40. Yes, so we have generated an equation for this Venn diagram. But Venn diagram, it is in such a way that the moment you represent the information on the Venn diagram, you represent this all this information on this diagram, you get half of the mark. If the whole thing is supposed to be 10, you drawing only the Venn diagram gives you 5 before the rest of the marks is awarded for the generation of the equation. Now let's see, minus x plus x. So this and this, they will go away. This and this, because minus x plus x, it has neutralized themselves. So now we have 30 plus 20 minus x is equal to 40. Now we are grouping the like terms. This and this will give you 50 minus x equals 40. So now we have to make x the subject of this equation. Therefore, for convenience sake, let's bring the x here to this part and then the 40 here to this part. So to be 50, this is positive. The moment it crosses this line, it becomes negative. It becomes minus 40. This is negative. This negative sign here is affecting this x. So x jumping over the equal to sign will be positive. So this will be x. So this will be x will be equal to 10. Yes. So as you can see, this plus this gave us 50. 50 minus 40 gave us 10. Therefore, having gone through the whole procedure, we arrived at 10. So the best way or the fastest way for you, always when you are told to find the intersection, just add these two elements. After adding them, you just subtract it from the universal set, and before even you started, you know your answer. Yes, and there are instances that you'll be giving the complement. You'll be giving complement or presentation in the fourth region. That one too, the time will come for us to be talking about that. So for now, that is that. So we can see that 30 minus, now we have realized that this is 10. So 30 minus 10 is what? It's 20. 20 minus 10 is 10. So this plus this should be equal to this, and it is true. As you can see, not this plus this. This and this, they contain members who are here and members who are here at the same time, as I just explained to you. Now if you don't take care, you will count people more than twice, and that is exactly what has gone on. Let's go to the second question. In a school of 225 students, hold on.
Me add down now a pause one.
Look at the question again. Now, in a school of 225 students, 80 study Arabic only, and 125 study French only. Each student study at least one of the two subjects. Now, with this, let us be very particular about the word only. Only. It means those students, they are not here, they are not there. They study one subject. So let's try to represent that information on the Venn diagram. There are 225 students. Arabic. Arabic, 80. And then French, 125. Yes. Draw a Venn diagram to represent the information. So we have drawn a Venn diagram. This is 80, this is X, this is 125. So everything here, this is how we have interpreted it using the Venn diagram. Now, all what you have to do at this stage is that the whole student, they were 225. But this plus this should be something. Each student studies at least one of the two subjects. Draw a Venn diagram to represent the information. How many students study both subjects? So both subjects. We have to look at this point. Now let's generate an equation for it. This will be minus x, 125 minus x. So 80 minus x plus 125 minus x equals 225. This and this will go away. This and this will go away. So it will be left with 80 plus 125 minus x equals 225. This will be 80, this will be 205. 205. Please hold on, let me look at the question again.
Continue.
Okay, so now over here, this plus this will give us 205 minus x equals 225. So this will be, we group the like terms together. 225 minus 205 equals x. So this will be 20 equals x. Yes. So now our x is supposed to be 20. 20. This is 20. So 60, this one, because 80 minus 20 will be 60. 60 with this 80 plus this should give us 225. So that is that. Now I will give you subsequent videos and then audios about Venn diagrams, because this is just a part of it. And at the ordinary level, Cambridge, you deal with only 2 set problems. So we are not going to go into 3 set problems. We are limiting ourselves to 2 set problems. After this, I'll give you an audio too, explaining much about what I've just demonstrated on the board. So I hope those who are having access to the video, they will get. Those who are having access to the audio, they will get. If you are not having access to any of these 2 platforms, you can come to the gate and there will be photocopies of everything that I have given online at the gate, waiting for your collection, so that you do it, you give it to your parent, you submit it. Or if you have access to the internet, you can go there, you can go to the YouTube, explain, listen or watch whatever which has been deposited there, and then you do the follow-up questions. I hope I've been able to convince and teach you very well. Any other comments or any questions can be WhatsApped through my private number. Don't bring it to the general platform. Bring it to the private number, and then I will know the explanation to give you. Thank you very much. Until we meet the next time. Bye-bye.